Okay, you got it there? Page 84, number 5. Okay. So firstly, we should see which is the smallest number. Which is 1.7. Yeah? 1.7?
Yeah.
And the largest? 9.5 I can see there, yeah. So the range is 0.25. Also the n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16?
Yeah. So 4.
Yeah. Closed, open, closed, open, closed, open, closed, closed. So I can get the last one. The smallest is 1.7 and the biggest 1.95. So if I've got 4 pieces and it's 0.25, well, I can go over a little bit. Let's see, if I go up in 6, 7, 7, 14. Maybe, I'm thinking maybe if I go up in pieces of 0.0. No, I don't have to be, I can make them a little bit bigger if I want. If I do 0.07, that would take me to 28, and if I was to do 6, that would take me to 24. So I'll go up in 0.07s. So the first one here, you know, I'm going to just...
Mr. Stephen?
Yes.
Like if I take now 0.25 and divide it by the number of classes.
4, yes.
Yeah, and then I subtract to have the first number.
Yeah.
And then...
That's fine also. But I'm making my life easier by making it a little bit bigger so I don't have so many decimal places. Because you said it was like 625 or something here, wasn't it? Yeah. That's all. Just making things a little bit easier. Here it will be 1.7, 1.7, instead I'm going up in 7s. So 7, 7. 1.77 to 1.84. 1.84 to 1.91. And then 1.91 to 1.98. So it doesn't matter, I got a little bit over, but it makes it easier to write. So I can live with that. So the first one, 1.7 to 1.77. Is it 1.1, 2, 3, 4, I think, if I don't count the 7, 7. And then the next one, 7, 7 to 8, 4. 1, 2, 3, 4, 5, 6, 7, 8, I think. And then 1.84 to 1.91. 1, 2. Then 1.91 onwards. Hang on. I'm missing one.
Yeah.
No, I'm not. There's 16 there.
Yeah.
Isn't there?
No, 16.
Sorry, no. I'm missing one. There's one missing.
No, the first one.
Why probably the first one?
First one is 5.
There should be a 5?
Yeah.
Are you sure?
Yeah.
Okay. That's it.
Who wants to find the 1?
Yeah. I kept adding this number onto this. So I added once, added 2 times, added 3 times, added 4 times. And then this number was this divided by 4. And it's okay if you want to round up a little. It just means that at the end you go over, which is fine. If you go a little bit over, it's acceptable. There's no problem. It makes it neater too, because there's only one significant figure here instead of 3. It's messier. You got that? Write that down, and then we'll look at the next topic. Yeah. Here you go, Ali. You don't need it just yet. Okay, do you have that? Yeah? Yeah? Okay. It will be helpful if I have this. This one. Okay. So you remember a little bit ago we looked at something called median. So, well, we're looking now at quartiles. In fact, you did a quartile problem already. The median is like a quartile. The median, if you remember, for the median, you put your list in order from the smallest to the biggest. You remember that? And then where is the median? The middle number. This is where the median is. So we're going to look at a similar idea called quartiles. We have the lower quartile and the upper quartile. So if we think of the median being in the middle at 50%, then the lower quartile is at 25% and the upper quartile is at 75%. Or, another way I think about it is the lower quartile is the median of the first half and the upper quartile is the median of the second half. So this is the lower quartile and this is the upper quartile. And in fact, we normally call this one Q1, and we call this one Q3. So no surprises, or no prizes for guessing what the median is supposed to be, Q2. Yeah. In fact, you could even think about it more like this. The minimum would be Q0, and the maximum would be Q4 then. So we're breaking our data up into 4 pieces. Anyways, the lower quartile is here, and the upper quartile is here. Yep. Okay. Let's have a look at an example. So let's take some data. Okay, so write this down. This is our first example. Why so late, Ayub? Come back for the second class. Okay, you got that written down? Yeah? So the first thing we do, what do we do when we're calculating the median? What do we do first? Rearrange them. So what I'll do is I'll just copy this and I'll put it in order from smallest to biggest. Like so. Yep. Now, how many, oh, you know what? Rats, I kind of want one more. Let me just stick one at the end there, 10. Okay, how many numbers do I have here?
4, 2, 3, 4, 5, 6.
7. So where would the median be of these 7 numbers?
5, 4.
Yeah, what position? It will be in the 4th position, which in this case is 5. So it goes 1, 2, 3, 4. So here is the median, which I call Q2. So if we look here, this is like the first half. Let me put that in a different colour maybe if I can. Where the heck are colours? In colours? Font colour. That did nothing. Sorry, that's not doing anything. Font colours. Ah, alright. It's not wanting to cooperate. Well, use your imagination. I'm highlighting these. Let me put them in italics. Okay, so these is the lower half. So what's the median or the middle here of these 3 numbers?
4.
It's 4, yeah. So this is Q1. And then for these ones here, 7. So this one here is Q3. Whoops. Q3. Oh, that's something, I suppose. Okay, I put a box around these, and then I put a box around these. Alright. This is the lower, and then this is the upper. Yep. Now, tell me, before I did this one, was anyone thinking about the 5, if I should include it in calculating the lower quartile? Because I think most people were looking at these 3 numbers, and they took the middle of this. But maybe you should take these 4 numbers here, and take the middle. Because after all, you know, that would include the median, which is at the middle. And in fact, this is a problem. Well, not that it's a problem, but if you think about it, you can either do this. There's the start, there's the median, and there's the end. So when you're calculating the lower quartile, you can have like 1, 2, 3, 4, 5, 6, 7. This is what we have. So some people might be thinking, well, maybe we should include this. And then what would be the lower quartile? It would be the middle of these 2 numbers. Isn't it?
In this case, it's going to be 4.
Yeah, in this case, it would be 4, and we include the middle of these 2. And you might say the same for this one here. We would include these 2. But if you don't count this, so if you delete this, and just look at these 3, then where would the median be?
Number 2.
Yeah, it would be this one, not the middle of these 2. And likewise here, it would be this one. So you can see that the answer is a little bit different. Let's do this again. But this time we include the median and see how different the answer is. So this can be the lower, and then this one can be the upper half as well. So if I have 1, 2, 3, 4 numbers, it would be the middle of these 2, wouldn't it? Oh, sorry, they're not in order. Okay. It'd be these 4. So the median will be the middle of these 2, which in this case is, it's still 4. So you'd have Q1 equals 4. Although it changes now for the second half. The middle of these 4, what would that be?
6.5.
It'd be 6.5, wouldn't it?
Yeah.
It'd be 6 plus 7 divided by 2. And the median is still here. It's still 5. So I mean, it's not a big difference, but it's still a difference. So you can include the median or not. In fact, the choice is up to you. But it's important that you say in your answer which method you're using. It's not a big deal. In fact, the syllabus doesn't care which method you use. Just make sure you say which one you're using in the exam. So you could say, if you did it this way, i.e. the method that excludes the median. And then if you did it this way, this would be the method that includes the median. In fact, there is one more method, which I'll show you now in a minute, but I'll just let you write this down.
This is when a question comes to calculate the quartile.
The quartiles, yeah. Mm-hmm. Okay, so method 1, here it is here. We don't include the median and take the number in the middle and the number in the middle. And then method 2, we do include the median, and so our number in the middle will be a little bit different. In this case it's the same because it's a 4 and a 4, whereas in this case it's a bit different because we have a 6 and a 7. So it's a little bit smaller. So there's actually one other way you can still calculate it, or one other method. I wonder if anybody has any ideas. So in the first case I excluded the median, in the second case I included the median, and in the last case, any ideas what I could do, my sort of method 3?
If you have including of
No, nothing to do with odd or even. Include all of them? Well, that's kind of like method 2. So, anything else? No? It's not clear, but
Find one and use the percentage and
no.
choose one.
Method 3 is choose method 1 or method 2.
Yes.
No. Method 3, in fact, is method 1 and method 2 together, and you take the average of the two results. So method 3 here, this would be 4 plus 4 over 2, which is 4, and this one here would be 7 plus 6.5 over 2, which is 6.75. So this is the method you should not use in the exam because it's the longest, because you need to do both. So this one you can use for the exam, or this one, but not this one. But this one here is probably the most accurate. So this one would be although it's the best one, it's also the longest to do. These are okay, but the advantage is they're quicker, which is important for the exam because you only have 2 hours. So there are the 3 methods then. In the workbook I called this method exclusive of the median, and this one I called inclusive, and then this method I called arithmetic. Arithmetic meaning, you add the two together. Yeah? There's still a couple of more things to look at, but first just make sure you have these 3 examples clearly written down. And it'd be nice if you had different colours to maybe put this and this in different colours, and this in different colours. Or circles or something. So you could put a circle around these 3, and then a circle around these 4, and a circle around these 4.
look at the 3 is not involved. Look at the 3 is not involved.
No, method 3 is the most important one, but you don't use it in the exam because it takes too long. Sorry, that should say 5, not 2. You got that? Yeah, I can go to the next thing. Yeah, okay. Okay, the reason quartiles are important is because it can take your data and put it into a group of most common. If you think about heights, if I put people in order of their heights from smallest to tallest, then the median person is here in the middle, the lower quartile person will be here, and the upper quartile person will be here. I really care about this group here. This is the median person, this is the lower quartile, and this is the upper quartile. I really care about this group because this group what percentage of the total do they represent? 50. Yeah.
So this is
From Q1 to Q3 is 50% because
there's 25%.
yes, because these people here is 25%, and these people here are 25%. So you know, if you're talking about medicine or manufacturing or clothes or whatever, you care a lot about these people because this person here in the middle is the average, and then these are the people which are near the average. These people here will be very short, and these people here will be very tall. So it's this middle group that you care about. Yeah. So this gives us our reason for the next idea. Idea is called the interquartile range, or just IQR for short. And in fact, it's just the upper minus the lower. It tells us how big this group is, their range. So we'll calculate it for the example of data I gave a moment ago. But interquartile range is the upper minus the lower. Please don't confuse that with the word range. Range by itself means the maximum height minus the minimum height. This person minus this person. Sometimes in the exam they try to trick the student by asking for range in the statistics question, and then students calculate this instead. So please be careful. This is called the interquartile range, whereas this one here is just called the range. Yeah? Okay. Can I go back to my data for a moment? Yeah? Okay, so let me just get rid of these notes here. So let's calculate interquartile range. So for the first group, it would be what minus what?
4 minus
7 minus 4. 3. And in this one here?
6.5 minus 4.
Right. And then here? 2.75. This is the interquartile range. And by the way, what would the range be? So for the first one here, what would it be? 10 minus 2. And in fact here it's also 10 minus 2. And here it's also 10 minus 2. So you have interquartile range and range. Yeah?
7 minus 4 is
For which one?
for the interquartile.
Yeah, 7 minus 4. Yeah. 6.5 minus 4. 6.75 minus 4.
And for the range is 10 minus 2.
Yes, 10 minus 2. Yeah? Okay, I know we did standard deviation last week, but I just want to show you something here if I calculate it. So let me just calculate it here. Do you notice anything interesting about standard deviation and interquartile range? No, I mean interquartile range and standard deviation, if you compare the two. They're kind of close, aren't they? And this is not too surprising, because if you think about it, what did I say the standard deviation represents? It's kind of, on average, how far you are from the average. It's like how spread out you are. So if the data is very spread out, if you have very small and very big people, it's very wide, which means the interquartile range is very wide, which also means that the standard deviation is very wide as well. Let's have a look at a bigger data set to see if we can get a better idea. So if I just go here, You don't need to write this down. Okay, can I go to a new tab? Yeah? Okay, let's make a random. Random. Okay. How many will I want? We'll go to 100. Okay. So let's see, I can use Office to calculate the upper quartile. I think the function is called quartile. Yeah, which is nice. So my data goes from A1. I know. I'll fix it. A1 to A100, and if I want the lower, it's Q1, so that's a 1. It's fine. Okay, and then here I want the upper, which is Q3. So then the interquartile range would be this number minus this number. Minus. So this is interquartile range. Now the reason it keeps changing is because it's random. There you go. Now let's calculate the standard deviation. It should be, because all the numbers are going between 0 and 1. Oops. There it is there. Small. Now, you can't quite see it here because my data set is so small, but normally the relationship between the two of these is that the interquartile range is roughly twice the standard deviation. Now it's not exactly twice, and in fact you can see here it's not exactly twice, because if it was twice this should be 0.6, not 0.54. But my point is still this: when you have a large data set, and this is not large, there's only 7 in it, but when you have a large data set, interquartile range should be roughly twice the standard deviation. And this is useful because it lets you know, if you calculate these correctly, that this number should be roughly twice. Now if the data set is quite small, you can see in this example here they're actually nearly the same. I think I had like 2.52 or something here. But anyways, for large data sets, it should be about twice the same. So we can have, if n is large, interquartile range is equal to twice the standard deviation, roughly. And then if n is small, the interquartile range could be somewhere between 1 and 2 standard deviations. In my example I did, it was closer to this one. But as it gets bigger, it should become closer to this one. So this is another reason why interquartile range is useful, because it's easy to calculate and it has a relationship with standard deviation, which is difficult to calculate. This is a very common question in section A, and in fact what I'll do is I'll let you try these for a few minutes, and then I'll do some section A questions from past papers showing you what these look like in the exam. Okay? But they're always like this in section A. What happens is they give you some data and they ask you for the quartiles. And it's not difficult to do, and it's usually 5 marks. So it's quite good. Okay, so I'll let you practice these for a few minutes and then I'll do some exam questions on the board.